let's continue. That solves one question. Now we need to continue. What's next is, I guess my next question is, how do you, because you need to trace back, right? You need to trace back. How do you trace back? By trace back, I mean, because think about earlier. You said I'm starting from H, then I'm moving right, I'm moving to F, that's okay. You're moving forward. You're moving to D, that's okay. Then you're moving to F, another F, right? You're moving right to the F. Then you say, okay, this is a bad decision. I've seen F before, so I need to what? I need to trace back. And to step back, I need to go back to D. So how do you want to do that? How do you want to go back to D?
Well, okay, I've implemented like this maze walking algorithm before, and the way I've always been doing it is recursively.
Like good.
Like you call onto you have two parameters, x, y, and that's where you are in the matrix. So if you're on D and you go right, that'd be like, let's just say x plus 1y. So like at the start, you can check if the value in that position of the array is 1, and if it is, you return without adding it to the array.
Let's start, you check the value, you can return. But okay, so that works for one step, right? What you are describing is look forward, right? You look, so you're saying is before I step to the next one, before I move, I look, I check. If it's bad, I don't move, right?
Yeah.
But now you have a bit of additional question is, what about letter D? Because now think about this. Letter D will look right. That's F. No, that's bad. I'm not going to move. If you look letter H, that's bad. I'm not going to move. Then letter D is out of options, right? What's your next? So letter D will have to step back, right?
Yeah, if it's out of options, then it can't recur. So it just end the function and then go to the previous recursive call.
Okay, good. You end the function. So you're going to go back, which means before ending the function, well, let me see. You can do it after, right? You can do it after. Now, but the thing is, how so this one, your recursive call pretty much handles most of it. But you need to remember, you need to still remember something, right? Because anyway, you tried. Because you still need to understand how good or how bad this path is. Right? Where do you remember it? How do you keep track of the best solution so far? That's what I'm trying to say.
Well, the best solution would, you can like keep a variable of the array's length. And then if the array, or not the length, the amount of values that's 1. And then if the value that's 1 is ever longer in a recursive call, then that's the new longest. And then you don't change the longest until there's a
I see. You want a global variable.
Yeah.
Is that what I mean? You want a global variable, you want each recursive function to be able to update that global variable. That will work. Okay, you answered that question. So how to keep track of longest? You use a global variable. That's okay.